In legacy resin-based additive manufacturing processes, maintaining viscosity in a low range is crucial for guaranteeing a stable material process and printability of the parts. VLM technology can process at room temperature resins from 20 pascals second to beyond 200 pascals second. This opens a wall of possibilities when formulating photocurable resins, and finally unlock all the barriers that AM face for providing solutions that can compete in real production environments. But why is high viscosity so important when formulating resins? First, extended available ingredient set. With high viscosity resins, material scientists can incorporate a higher fraction of oligomers or various additives, fillers, and modifiers to tailor the properties of the material to their specific requirements, such as enhancing mechanical strength, improving thermal resistance, or achieving desired surface finishes. Second, strengthening the polymer matrix. In high viscosity resins, polymer chains are longer, leading to a less cross-linked network. This translates to a tougher structure in rigid materials or better elastomeric properties. And third, mitigate thermal aggression. VLM technology with high viscosity resins eliminates the need for heating steps. This absence of thermal aggression ensures consistent properties among layers, resulting in uniformity and predictability in printed objects. To explore further the pivotal role of viscosity and discover how VLM technology is enabling the production of end-use parts with resin-based processes, visit our blog at supernova3d.com.